Hello and welcome to Adventure Time with Mr. Pig. Today I'm going to talk to you all about the carbon cycle inside the process of making bacon soap, otherwise known as saponification. Saponification involves the hydrolysis of an ester to form an alcohol and the salt of a carboxylic acid. In this video, the carbon starts in the atmosphere. Then, plants use the carbon from the atmosphere to make energy using photosynthesis. This plant energy is then eaten by pigs like me or other animals. As I eat more and more grass, I am being prepared to get The fat from my body is then used to make bacon soap. Chemically speaking, this means adding my fat, the triglyceride, a strong base, in this equation, lye, or sodium hydroxide, and water, then using that water and heat as a catalyst reaction to make soap. And in addition to soap, glycerin is made. Water is used to wash out the glycerin and just leave the soap, which is then used to wash your hands and body. When you use bacon soap to wash your hands, another chemical reaction also will be occurring. When the soap and the glycerin molecules combine with water, they form a bicarbonate ion. This is what happens when soap mixes with water. As I said before, when soap dissolves in water, carboxylate anions and metal cations are produced. In water, the nonpolar, hydrophobic, long hydrocarbon chains at the end of each carboxylate ion attaches to nonpolar dirt, grease, and oil. The hydrophilic carboxylate anion end is attracted to polar water molecules by ion-dipole interactions. Now in aqueous solution, mixed with water, the soap runs down the drain. From the drain, these hydrocarbons are emptied out into the ocean. This relates to global climate change, as the more carbon molecules are put into the ocean, whether from the burning of fossil fuels into the atmosphere or drain pipes like this, the warmer the ocean gets and the slower ocean circulation becomes. Water trapped at the surface becomes saturated from fossil fuels, which means that the ocean will eventually slow down its carbon uptake. The problem is, the more carbon is absorbed in the ocean, the lower the water's pH becomes. This means that the ocean is becoming more and more acidic and less hospitable to plants and animals. Subsequently, we know that carbon dioxide can be released into the atmosphere from the ocean, which also contributes to greenhouse gases, also warming the earth. In the ocean, algae, plants, and even fish may use the carbon from these hydrocarbon molecules for photosynthesis or other chemical processes. Take algae, for example. The carbon from the hydrocarbon goes into the algae in the process of photosynthesis. Then, a fish may eat the algae, and just like I earlier ate carbon, so does the fish. The fish uses this carbon for its chemical reactions and processes needed to make it healthy and alive. We can travel up the food chain as the fish is eaten by a bird. This bird then uses the carbon inside of the fish for its essential chemical reactions and processes. Later, the bird poops on your car and in the surrounding area. This carbon from inside of the bird's waste is then used by decaying organisms in the soil and grass. Similar to elements like nitrogen and phosphorus, The roots from the grass inside of the dirt then take the carbon and use it for its essential chemical processes. We are brought full circle again as I eat the grass, over and over.